Good afternoon, everyone. Well, welcome to the last session of the day, the second day of our Digital Innovation Summit. Now, we have one more day to go. We have another three wonderful sessions for you tomorrow. But today, this is the last one for the day. We are honored to have Hakan Göktaş and Dr. Hakan Göktaş with us. He's going to talk to us about model risk management. Hakan has a number of years of experience in this field, and he's currently the global head of model risk management at American Express. He runs a team and along with himself and doing model risk and audit and etc. Now, prior to that, and he has worked at a number of the financial institutions, such as like State Street and being the head of probability default there. And so he's absolutely an expert in the areas of financial risk management, credit risk and financial modeling, model validations, sampling, fraud detections, and statistical modeling and simulations. So it is a privilege and an honor and for us to have Dr. Göktaş join us today. All right, Hakan, take it over.
Thank you, Bruce, for the introduction. Let me share my screen. So I prepare a deck so we can, I think, Crystal, if you can let me share the screen, share my screen.
Just gave you co-host ability. You should be able to do it now. Okay,
thank you very much. And I do this when I teach. I asked multiple times, can you see my screen? Can you see the deck? Can you guys see my deck?
Yes. Good.
Okay, let me put this on the presentation mode. The beginning. Okay. Let me move things around. Okay. Today, I am going to talk about model risk management. This is a disclaimer slide. I was told by a legal department to talk about it. Basically, nothing in this presentation should be taken as information regarding or description of any operation or business practice or risk or other control or assessment procedures of American Express company and it is affiliated companies. Let's get this out of the way and let's talk about the model risk management framework. So basically, what is model risk? Why do you need to care about this and what are the implications of it? Right? If you just think about it, pause and think about it, 20 years ago, like how did companies make decisions? Right? When 20 years ago, when the companies made decisions, most of those decisions were not backed by sophisticated statistical analysis or sophisticated data analysis, because most of the companies.
Hakan, can I interrupt you for a second? Looks like you are in the presenters mode that you're showing the presenters view. So if you can just switch that to just the slideshow, and so that the audience can see the slideshow.
Sure. Thank you for correcting that. Okay, let's see. Okay, share. Okay, now it's better, right? Okay, now basically, why do you care about the model risk, right? 20 years ago, most of the decisions when the companies made decisions, those decisions were not backed by comprehensive, complicated statistical analysis or data analysis. The reason behind was that is they did not have that data available to them. But at this age, everybody is collecting data, right? We are talking about data scientists, right? Became a new field as a result of it. And companies have an enormous amount of data, and they use this data to make decisions. For example, simple example is if you are buying a house, when you apply for a mortgage, right? There is a model running behind the scene saying that, okay, this person is a good customer or a bad customer. Or it tells you your risk level. Based on your risk level, there's another model runs behind the scene and say APR rate for this person should be X%. So every decisions that companies are making, right, there is a model behind this, right? Imagine if this model was wrong. So what will happen, right? If the model is wrong, it will have financial consequences for the company. Basically, you make the wrong decision, you give multi-million loan to wrong person, etc. And if you, this is not only financial implications, but you probably heard about the news about gender bias, models are being gender bias or race bias, etc. If the model is wrong, there's something wrong with it, it will also cause you reputational type of issues in the market. So that's in the availability of the data, enhancement in the AI and ML amplify the model risk. So why will model give you a wrong prediction? There are multiple sources for it. First one is plain simple one. You did not build the right model. There is something wrong with the model. Either is the design is wrong, you picked the wrong algorithm, etc. Second part is something went wrong operationally, right? What do I mean by it? So model was right, but IT department, when they implement the model, they implement the wrong model or they make mistakes. Or the third one is you use it incorrectly. Is that happen? Yes, it does happen. Everyone will face that. For example, I went to one meeting. Let's say Bruce built a really cool model, nice model. I really like the model, but I really truly understand the purpose of the model. But I thought it is a machine learning model. It will make me look good if I use this model, and I use the wrong model, or the model was right, I use it incorrectly. So this is all source of model risk, right? That you need to think about how to validate it. And initially, like after first financial crisis in 2008, when all the models failed, right? Because none of those models in the financial institutions did not see this market crisis coming, as well as after the market crisis, models were even after recalibration, models were again not predicting numbers accurately because of the wrong practices, right? Because when we say model validation, model risk, everybody thought about that red box that you see, model validation. But model risk is more than just looking at the validating the model, which we call it model validation. It's more than that. So basically, model validation is done by an independent set of data scientists or quants. Well, they will not participate in the model development process. They go in there. Basically, they validate your model. Basically, they assess that you picked the right methodology, you built the model correctly, your model performs appropriately or adequately for the company to put the model in use. But model risk management framework is more than that, right? It's about also change management, because models are constantly being changed, whether it is being recalibrated. Recalibrated means that refresh with the new data set or redevelop the overlays, right? Or you need to inform the board of directors and senior management about the critical models and model risk, ongoing monitoring, policy and procedures, and etc. So if you can see this picture, it is very comprehensive, right? And it could be very complicated. So what did regulators did after in 2011 is they introduced a 3-line of defense concept. So this is applicable for any financial institutions. Basically, first line of defense is modelers, basically people that building these models and using these models. They call this group of this group first line. Basically, they are responsible for building the right model. They are responsible for establishing the right level of controls. They are responsible for doing ongoing monitoring, identifying model breakages and escalation processes, etc., change management. So pretty much they are responsible for everything. Then second line of defense is basically this independent group is providing effective challenge to first line of defense. Also, second line is also responsible for designing the model risk management framework for the company, as well as risk appetite framework for the company. And the third line is internal audit group, is responsible for making sure that first and second line of defense are doing their jobs. Basically, the first line is appropriately identifying the risk. Second line is appropriately providing effective challenge to first line, as well as their model risk management framework is proper and comprehensive. I think for those of you not familiar with the financial institutions and as well as our current and prospect students wants to get in the financial institutions as a data scientist, you should be familiar with those regulatory guidances. SR 11.7 or OCC 2011-12 is the main guidance on model risk management. There is also 1518 and 1519 for capital planning, and there's OCC heightened standards, which kind of based on those two regulations, but it's more descriptive. Now, let's talk about SR 11.7. When regulators wrote this guidance, SR 11.7, in the financial institutions, logistic regression model and other type of regression models basically primarily make almost 90% of the models to be used in the credit risk. And in market risk, there is no much of, we'll talk about it a little bit, but in terms of use of AI and ML in market risk, there is no much movement in that space, most of the movement on the credit and fraud space. When the regulator wrote this guidance, SR 11.7, it was written primarily assuming that we were building using some type of a regression type of model. But now, as I am going to talk about AI ML, modeling techniques are different, right? The concepts are different. Risk are different. For example, when you look at the regression model, how you build a regression model steps, how you build a machine learning steps, there are, in theory, you can argue that they are similar, but in practice, they are quite different. For example, in regression model, you have to worry about correlation among the variables. Machine learning models, that's not the case. Ongoing monitoring is a big thing. Machine learning is also a big thing. Ongoing monitoring is a big part of it. But if you are recalibrating your machine learning automatically every quarter, every 6 months, so what does it mean? So there are there are nuances, there are differences, which we expect. I personally expect the new regulation come out and explain what will be the differences. But this is a good way for me to switch to AI and ML. And if you have any questions, please let me know. We can make this interactive. So, what is an intelligent automation? Let me explain this by an example. Right? Let's talk about an autonomous car. Like, let's say Tesla or any other car that driving by itself. Like when you drive the car, let's say you are a good driver, right? When you see a person crossing the street, about to cross the street, you visually see it, you slow down, and depending on where the person is, either you let the person go or you cross the pedestrian's way slowly. Right? Or you see an accident, you slow down. When you change lane, you give your signal, you check there are no cars, and you change lanes. And you make those decisions very quickly. Now, let's think about it, how we are going to have a machine make those decisions, right? That's what intelligent automation means. So we are trying, the capability of a machine or software to intimate human behaviors. Like that's what intelligent automation is. Now, what is machine learning? Machine learning is a subset of intelligent automation, is set of algorithms to help machine to make those decisions. For example, you for car, you have a car as a camera, needs to record the image. Image needs to be by using set of algorithms, need to be processed, right? If you see a person about to cross the street from your camera, car needs to stop, right? So there has to be a set of algorithms running behind the scene, telling the machine is identifying this is a person crossing the street, and I am going to stop. Car is going to stop, right? And these algorithms are called machine learning algorithms. So why sometimes we call is a learning, right? Machine why we call it machine learning, right? Because let's say there's a mistake in the algorithm, right? Car got in the accident, right? Then you need to go back and learn from it, right? You need to fix your algorithm, so your algorithm next time the car does not make that mistake. So we are not at this stage at the Terminator movie that machine is going to learn by itself. There is a human interference is right now going on. So data scientists will look at it, identify, look at the root cause, why algorithm failed, and try to fix that algorithm and rerun the model. Then when the model rerun, you again look at the outcome, you see it, what is working, what's not working. Again, you go back and redo it again. So example of this in the financial institutions, let's say I use the same machine learning model to give you a mortgage loan, right? So did I pick the right people? What is my default rate? Let's say I give mortgage to 100 people, 10 of them defaulted, right? So it means my default rate is 10%. So I run my algorithm again by either putting new variables or changing my algorithm or refreshing my data to try to reduce the default rate. So I am constantly, data scientist, constantly involved in the process and try to improve the performance of the model. So this is basically machine learning, right? What's a deep learning? Deep learning is a subset of the machine learning. Basically, when we say deep learning, we are talking about complicated neural network models. And I'm not going to go into it. Unstructured and unlabeled data. But unstructured data, basically, typical example of unstructured data here is text data, is unstructured. Structured data is basically, I have your FICO score, your age, your income is clean in each column. That's a structured data. And that you'll see deep learning models being used. Where is the financial institutions with those methodologies? Mostly on machine learning, deep learning. There are some level of experimentation, but most of the financial institutions are using machine learning models for their mostly for their credit and fraud portfolios. Now, where are we? This slide shows the evaluation of AI, intelligent automation. Right? It goes back to 1950s. It amplified the last couple of years. Right? You see more examples of it. Right? When I was in grad school, there was we don't have a discipline called data scientist, right? Now with the increased algorithm, right? Because now you have new, fast, accurate algorithms, and you have the availability of the data. Then the data science field evolved, right? And as we are going to talk about more on the slide, as the companies are making more investment on this, it's going to keep, it's going to be one of the hottest job in the market. Okay, let me put this in the So as a whole, like in practice, right, making AI is simple, right? Basically, you collect your data like any other modeling framework. You clean the data, you process the data. Only difference in AI versus traditional regression models are here is AI, you have capabilities of using many variables, right? With the typical regression models, you don't have that capability. But AI, you can use 400 variables, 500 variables. You can import, literally, you can run your model on the entire book, entire data set. Like size of the data set is a less of a limitation for AI than a regression, typical standard regression models. But future engineering, basically, you need to you spend most of your time building, identifying variables to put in your AI model, right? That's a really cool step. That's also one of the strengths of the AI, as well as we are going to talk about what could go wrong with the AI model risk perspective. That's also main source of it, right? If you put enough data set, right, inherently you can identify that someone race, someone gender, right, then that could cause bias in your model, right? But when you collect the data, create new variables, we call it future engineering. Your step is the same. You have the training data, test data, then you build your model, making sure that your model works perfectly both on training and test sample. Then you go into production. But as we are going to talk about it, it's not that simple. Now, what's the we have the financial institutions, we have the tech companies. When it comes to AI and ML, tech companies are leading the industry, right? And tech companies are the first companies to publish their principles. And most of those principles came about after they published when we saw news about AI is causing bias. AI is like, there were a couple of examples I will go on over the next slide. And basically, Google has basically six, seven principles. I'm not going to read all of it, but basically it should be social, beneficial, avoiding creating unfair bias, tested for safety, be accountable to people, privacy, excellent standards, be made available for use cases. So when you look at all of those principles, and you are going to see more companies coming forward and putting AI principles, they are going to basically they are going to say we are not causing bias and privacy, right? We will be respectful for the privacy, and we will be using our ethical standards. We are not going to share your data. It's going to be around those points that with machine learning AI has been criticized. Because if you think about it, I think we touch base in the panel discussion a little bit, right? When we say digital transformation, right? AI and ML is a big part of digital transformation, because you have data sitting around in your company from a for different type of data set. For example, you could have my spending habits, you could have my from Facebook, you could have my or whatever people are using these days, you could have my posts, you could have my tweets, etc. You can have complex algorithm running through those data, social data that's out there very fast, very efficiently, and you can engineer this data, right? You can mine this data, and you can say, okay, Hakan's political affiliation is X, Hakan's spending habits X, Y, Z. From the last vacation, he went this, and you can use this for marketing purposes and various other purposes that I am sure you heard the news, right, about. We'll talk about it in upcoming slides, but those are the things, right? It's really good for the company if it's used correctly and in an ethically, right? Because you can connect the dots, and AI and ML is a big part of it. Now, what KPMG did back in 2019, they reached out to 200 COEs, and they did a survey about AI ML, and they identify 8 trends. The first couple of them was really eye-opening for me. Like the first one is basically the CEO says, we didn't think that this will be evolving this quickly. We thought we have 3 to 5 years for AI and ML to evolve this quickly. So they realized that AI and ML is developed quicker than they anticipated. Second thing that they said, we have a silo approach, but we are deploying things separately, but there is a big things needs to converge. I think we covered this part of it at the debate too. And the third one is there is a demand, and every single COE in this survey said they are going to increase their annual spending on their capabilities, right? Roughly $15 billion dollars. And they also, for the fourth one, they also understand that this is going to be require large investments from our organization. Basically, you need to have the right talent, you have the right business processes, and you have the right governance around this. I mean, next slides, I am going to talk about the internal governance process, but also they also identify that they need to make investment on the internal governance process, and they need to focus on AI ethics and control, because this also becomes a hot topic with the regulators in the US and as well as in international countries, and how they are providing service, etc. And they also understand that AI will impact competitive landscape. But my key takeaway from this KPMG study was, if I summarize this for you, number one, COEs, they thought this is going to grow 3 to 5 years, but they find themselves in an environment that it is growing right now. And they also realize that they need to make investment, and they are anticipating that they are going to spend $15 billion a year. Also, they also understand that they need to make investment on their business processes, people, training, etc. And my area of expertise is also internal governance process that needs to be enhanced. I mean, I talk about a couple of examples, like this was on the news. Probably you seen it, read it. If you are more interested in, you can Google it and you can get more information about it. Since I work for a credit company, I am mostly familiar, like we studied the case for Goldman Apple Card process. So what happened with that? What happened with that is husband and wife apply for an Apple credit card. And even though in the family, wife is making more money than the husband, and when they both approve, but when you approve, you also given by initial credit line, and whatever the reason, even the husband is from a financial perspective is less worthy than the wife, because she is making from a financial perspective, she's better off. He got a much higher spending line. So then this was on the Wall Street Journal. It was on the pretty much all the others website. So it created a talk, and it also created a reputational issue for Goldman, which is the issuer of the credit company, etc. Is there a gender bias? How come husband ended up getting a higher credit line? And the model was used to identify a credit line was a machine learning model. I mean, this started a debate. Is this a bias? or is this something else going on, etc. But regardless of it, it increases the reputational risk. So if you are like, you don't want your company's name on a Wall Street Journal and another journal saying that your product you cause a gender bias. And another example is Amazon Scrap female resumes. There are most of the companies right now using machine learning based algorithms to go through the resumes. Basically, your model goes through your resume, especially for the companies that they receive significant amount of applications, right? Let's say you open a position, you work for a big tech, and 5,000 resumes come in. So you are not going to go over those 5 resumes by yourself. So you use machine learning model to go through this. But it was found out that machine learning model were biased, again, causing a gender bias. Again, then this brings a debate, right? Is this a really bias, or is there something else going on? Again, this news, regardless of it, it increase a reputational risk. Do you have any question, Crystal, so far, or should I take the question at the end of the lecture?
Yeah, we will have the Q&A toward the end, the last 15 minutes. So
okay, sure. I'll try to wrap it up quickly then. What is the regulatory landscape, right? So when we talk about the US, right, I'm a data scientist, right? When I look at the regulatory guidance, I am mostly focused on, is there going to be a regulatory guidance is telling me what I need to show the regulators when I'm building AI and ML models when I use them. So far, there were a couple of articles released, not articles, like communications released by the regulators. Basically, what they are saying here is SR 11.7 still applicable. Other existing regulations are still applicable, so you should be using them. And they are also say that they are also trying to learn the risk is posed by this new machine learning and AI algorithms. And there are some other guidances, right, being published by other regulatory agencies, but it's all about the same thing. Basically, asking the companies to develop appropriate level of controls, design your own controls, etc. There is no regulatory guidance release like SR 11.7 specifically for machine learning and AI. Because SR 11.7 basically breaks it down, introduces a 3-line defense function, as I talked at the beginning of the talk. What's first line supposed to do? How second line should validate models? How model risk management frameworks should be developed? What are the key part of it? It's very prescriptive. It's very well written. And my expectation is some regulation, maybe amendment to SR 11.7 will be published soon. Now, what is on the international markets? The international market, there are a lot more release after this, but most of on the data ethics and privacy, etc. And there was a latest one in UK about using scanning your fingerprints, etc., which also can be classified as privacy. Most of the guidances are privacy, but we expect to see more regulations being published by the in international markets as well. Now, as a data, when we look at the risk framework, right? I'm going to specifically talk about the model risk, right? This slide shows new risk as well as increasing risk. So let's talk about the first good things about the model risk, right? Basically, as I mentioned before, with the machine learning models, you have capability of building the models on a very large data set. Let's say, then you are wondering, what's that mean, Hakan? What do you mean by large data set? Let's say typical example. Let's say you are going to find let's say you are in you came to New York, you are lost on the street, you ask one person to give you a direction, then let's say you ask 10 person to give you a direction. So how you will make a better decision. I know it's not a good example, but the more data means that you are more capable of making the right decision. So let me put this in a financial term. So let's say you are going to build a mortgage model, right? If you build your model only 1,000 customers, it might not be large enough, because you want to ensure that your model captures your full universe. So in your model, if you are going to break down by occupation, you need to have enough teachers, you need to have enough number of police officers, accountants, mechanics, cab drivers, etc. The larger your data set is, you are going to make more accurate decisions, because you will have the history of all type of customers in your data set. So machine learning models basically will help you to use a larger data set than the traditional models. So it means you are going to be more accurate. When you use a machine learning models, algorithm works in a way that it will pick up any kind of nonlinear relationship, etc. Now let's look at on the negative side. These are what you are gaining here is you will have a more better model in terms of prediction. So you are more on target in terms of your predictions. So what are the risks? At the end of the day, you are using an open source code. Either you are using Python or R, you are downloading those open source code. So basically, you are relying on somebody else's code that you don't. You need to do some proper checking due diligence. Do you have enough skill set? Because most of these machine learning models, you are using cloud computing. You could be using AWS or other third-party cloud or third-party vendors to build your models. And biggest problem with the AI, ML, and that's the problem with the regulators is it a black box? Like, can I interpret your model? Can you tell me what's going on? Or this is just going to be the output, right? And you have a high dimensional inputs, right? And other biggest thing is overfitting, because AI, ML models, some people describe them as statistics on steroids. So it will give you a good short-term fit, but the long-term bust. So like you need to be very careful about overfitting. And we talk about the bias example, right? Personally, I believe that there are two sorts of bias. One bias is caused by AI. The other is the hidden bias in your data set. In your data set, for example, if there's a gender bias in your data set, like your company, whatever the reason is, in the past, you charge higher rates to females than males, or you have a racial bias if you charge higher rates to African American than in other ethnic groups, racial groups. So AI is going to replicate that. So it's not caused by AI. This is, you have bias in your data. Now it is, you are seeing it scientifically. Machine learning model is repeating the same thing. Other type of bias could be also is machine learning could do bias by itself, by its combination of overfitting and bias, right? You have to be careful about it. Other risk pillars, it is for your review, because these are not my area of expertise, but in each risk pillar, you see an increased risk dimension. Since I have 5 minutes before the Q&A. Let me move on to the next slide. Now, basically, so all the risks that AI is causing, right, you can put in the 4 buckets: resilience, integrity, fairness, and explainability, right? Basically, what happened here with the AI ML, we talk about in the panel a little bit, right? Now everybody has, with the digital transformation, now suddenly everyone is using AI ML models, because the open source code, you can download it, you have the data set, and you are using it. So like basically how we are going to manage this, right? How we are going to identify this. If you are using third party, like what does it mean, right? These are all risk areas, right? In terms of data privacy, how we are using it, right? For integrity, right? You need to look at like lineages between data. You need to understand usage of the data. For fairness, we talk about this a little bit. This goes into bias, right? How we are going to control the bias, right? Is it bias caused by the ML model, or is there a hidden bias in your data set? How are you going to control overfitting, etc.? How are you going to monitor this, right? And the last one is explainability, right? Because isn't this a black box, right? How can you explain this model? Or when you build this model, the model users, will they be able to understand the outcome? And will they be able to use it correctly? Those are the four pillars. And in last slide, right, some of it is you can by enhancing your design framework for each pillar, you can correct this. For example, whenever you are looking at this, you need to look at your existing model risk management framework, right? Let's talk about fairness, data bias, right? Like you need to be transparent on which variables, which features you are using, and you need to have a validation controls around this variables. You need to be looking at it like, is this cause a bias? You need to do independent testing, right? Also in your framework, you should be flagging models saying that this model is potential disparity impact. For example, if you are using models to approve people for mortgage, there is a potential this model should be flagged as the from a fairness perspective, for a disparate impact perspective, you should flag this model. Let's say if you are using a marketing model, let's say your marketing models, how am I going to reach out Bruce? Am I going to reach out to him by phone, by email, or by sending actual letter, right? If you think about it, is what is the bias in this here? If I reach out to Bruce by sending him letter, like, is this going to cause any disparate impact? Is he like, you need to, again, have a mechanism to first filter out which models that you have, you need to pay extra attention. After you filter out these models, right, then you need to look at the strategy you have, design that you have, and how you can strengthen those controls for use of each AI and ML cases. Again, most of the time it comes down to is flagging things correctly and identify where the risk is coming. When you identify where the risk is coming, you need to develop appropriate level of test and strengthen your design, and you need to have a mechanism to communicate this to senior management. For example, if you flag out 10 models and suddenly you see a disparate impact in those models, you need to inform the senior management, because if this is end up in the news, you'll be in the cover of Wall Street Journal for a disparate impact. Whether right or wrong, right, is a negative press that nobody wants. So again, the framework, you can manage the framework, but again, it is there are also some roadblocks. You need to make sure that you have the right skill of people, understand the risk, understand the framework, and you have right mechanism to escalate this to senior management. I think we are about time. I think this was the last slide, Bruce. We can open the Q&A session.
Okay, all right. Oh, thank you very much, Akan, for this wonderful presentation. What we're going to do now is that we will open up the forum and to interact with our audience here. And so for those of you in the audience, if you have questions, and please continue to post it in Q&A. I'm going to invite our colleague, Crystal, to help to facilitate the Q&A.
Thank you, guys. A great session we've had so far. So the first question that we have is someone posed the question and says, I have some risk management experience at a commercial bank, and if I want a career switch to model risk specialist, what studies or skills do I need to have?
I mean, you need to have understanding of the models, right? Basically, it really depends on the like if it's a financial institutions, you need the understanding of a regression modeling techniques, and now most of the financial institutions start to migrate over to machine learning models for their credit fraud identification models, as well as anti-money laundering models. So you need to have understanding of the machine learning models. But if you have prior credit risk management perspective, I believe you should be, like, depending on how you feel about your quant skills, you should be able to just apply because there are in this when you look at the commercial credit perspective, right? Not all models are used along with the fundamental writer. Basically, someone some underwriter will go through. For example, let's assume Apple apply for a credit card, Apple apply for a loan from your company. Someone may, or there's a person looking at this manually because getting the information. It's not fully automated yet because you have some risk management perspective. You should be able to, like, depending on the job description, you should be able to either apply right away, or if you want more quantific job, you need to brush up your stat skills, and as well as you need to take a class on the machine learning.
Thank you. I think that was a great answer. This is partially answered, but I'm going to ask it anyways. What was the explanation for the public, and what would be an explanation for data scientists of the woman bias case?
To be honest, public, I don't know because it didn't happen in my company. I think what I heard was here is they said it was not biased. That's the only thing I know. But behind the scenes, you know that there are multiple reasons that could have happened, right? Even though wife has more, making more money, maybe all the debt was under wife's name. Maybe mortgage was under wife's name, right? All the credit cards could have been under wife's name because she could have been the primary lien holder for the mortgage. She could have been primary lien holder for the car loans, etc. So that could have made her a little bit more risky because she, even though she's making more money, but she's also have more debt. So maybe husband did not have any debt, but certainly something went wrong with that decision. I think there was in my quant opinion, I'm just speculating, right? I think model did not like connect the dots that they were husband and wife. They were treated separately. I think that's the thing. But at the end of the day, you need to have a mechanism to identify this, right, before it goes into public, right? I think that's opened everybody's eyes because I don't think anybody was thinking about, okay, should we link people, because it is illegal to look at your marital status. It's illegal to look at your age or gender because models do not have those variables. But that's where the machine learning models comes into play. If I put 300 variables in the model, machine learning model could identify Crystal is let's say the person is Crystal. Can machine learning model somehow figure out algorithm, group all the women together? Maybe algorithm will find out Crystal's a female. Maybe, like, I don't know which variables are in there, but that's the whole talk about the machine learning models. When you put 300-400 models in the variable, are you going to granular enough level for algorithm to pick out and create bias on its own?
Great, thank you. I'm like, that was really cool. The next question we have is how can biases be built into models if the model restricts its inputs to mathematical results and economic data?
Can you repeat the question one more time?
Sure thing. It says, how can biases be built into a model if the model restricts its inputs to mathematical results and economic data?
Um, let's say, I don't know what you be referring as economic data. Let's say whenever you are building a model, right, it's a historical data. Let's say I apply for a mortgage. You have me in the model. My name is Hakan, right? Uh, Maybe in 1990s when there was no regulation, you deny me because I was a male. I'm just making this up. Maybe it's not a good example. Let's say there was a bias, some level of bias caused by underwriter. You reject me. Then you have this data in your data. Or typical example is when, let's say, racial bias, right? You have your data. The bias already exists in your data, right? Like because of the decision made in the past, because you are building your model on a historical data. If there's a bias in your data, what machine learning algorithm is going to do is not going to introduce a new bias, simply is going to look at, okay, some people like Hakan apply for a mortgage, you deny them, and someone comes in with the same characteristic I do, model is going to do the same thing, is going to deny them, because in the past you denied them, right? Because there is basically, we call this a hidden bias, because maybe let's say you're a large organization, you don't know what's going on, there is no way for you to quantify it because I did not sue you, or people did not see you, etc. Now, this is causing the bias because there's a hidden bias in your data, right? That's one part of it. Second part of it here is caused by the model, right? Again, algorithm works, again, it's kind of in conjecture with the hidden bias in your data. Also, model comes in, right? Maybe group me with the people with the low for economical characteristics, right? They will somehow I ended up in that group, right? Because model do overfitting. I call this as an overfitting, but if you are saying that this is a you can label this as a bias too, because you reject me, because suddenly you group me with the other group of people. Let's say we have same characteristic could be is they we are all of us our names is Hakan. So you model put us in the same group, not knowingly, and we let's say majority of this group is consists of the bad customers. Then model rejected you, then I will say this is bias against me. Again, it's just how we look at it. There's you need to be careful about the hidden bias in your data as well as the bias caused by the algorithm.
Great answer. I think we have time for about maybe one, maybe two, if we can sneak it in. This one has acronyms in them, so sorry if I pronounce them wrong, but it says, how applicable is the ISACA's CRISC certification to this type of work?
To be honest, when I do hiring, I don't look at certifications. I look at the relevant work experience, and I look at the academic training and course. Like if I am going to look for certification, I personally I don't. But if I'm going to look for a certification, I look for FRM certification, financial risk management certification for financial institutions, and that certification is not about machine ML and AI. It's more about your financial background. But again, for AI and ML type of background, personally, I don't look at any certification. I look at your resume, look for keywords. For example, do you know Python? Have you built any AI and ML models? And where you worked? So if you don't have prior work experience, I will look at your school. Like, did you get trained in the AI ML field in one school? Which school you get trained? Those are the things that I look at it. Again, that's me for model development and validation process. I will look at your validate your work experience, your skills, as well as if you ask me, give me a certification account, I will say FRM.
Thank you. I think we have time to sneak one more in. And the question is, does structured data help temper biases?
Not really. again, uh, not it doesn't cause bias, right? For example, uh, FICO score, right? Almost as a consultant, I've been name a bank. I've been there as a consultant because I work as a consultant for about 8 years. Built credit risk models for the various banks or validated their models. Every single model in the United States or Northern America, every single bank has FICO in them. And that's FICO is one of the most important variables. If your FICO score is 600, is it because your gender? Is it because your race? I don't think so. It is because of your financial, like how many times you miss your bill, etc. Right? But again, structured data doesn't cause bias. Right? You need to look at your data and understand: is there a hidden bias in your data set? For example, let's take a school application. Uh, let's say you're a uh, let's say you're a woman applying for a school. Let's say your name is not traditional American name, and you are getting rejected, right? Uh, and let's say this is bias. Let's assume the worst case scenario first. Let's assume this is bias, right? Then you are trying to build a model to look at the student's application, and you are going to pick students whether it is they are going to approve or not. So if this is the case, algorithm is going to do the same thing because there was a bias in your processes, right? So because what machine learning models are doing is slicing and dicing the data, find a homogeneous group to assign the right value, right? So if majority of the cases that you are deny those students in regard their high SAT scores, and there is no difference between them in terms of their SAT score, high school GPAs, or their background, right? Basically, they were rejected some other reason, right? This is not caused by the AI or ML. That's we call hidden bias, right? Maybe institutions don't realize this, right? This hidden bias in their data set. But when the ML model does it, suddenly people are saying that, oh, this is because your model doesn't work, there's a bias. No, because there's a bias in the data set. Then you need to, as a data scientist, you need to understand that once you understand there's a hidden bias in your data set, you need to develop strategies to solve it. And if your model is causing data bias, right, you need to test it. For example, when the car manufacturer develops a car, they are doing 1,000 tests before releasing it. When you build an AI ML, I'm not saying that you need to do 1,000 tests, but you need to do proper level of testing to find out if there's a bias in your data. Does the output is biased? Like you need to be conscious of this. I'm afraid to say it, but most of us, like I never thought about data bias until this becomes a news. For me, is my model is accurate or not? Am I making the right decision 80% of the time, 90% of the time? That's the metric that I was concentrated on. But now this all the bias news comes on the surface, then okay, now we need to pay attention to hidden bias, right? Then you need to, as a data scientist, it is your responsibility to develop, do initial testing to figure out if there's a data bias. Also, most of the companies, financial institutions, they have independent group which do fair lending. So they go around, they do their independent testing. So you are more protected for financial institutions rather than the tech companies. I don't think there's the same rigor. I don't know. I don't want to, but there's no financial regulations are different for the tech companies and the banks.
Thank you. Thank you. That was great. I know we have some more questions that were pending in the Q&A, but we are kind of at our time limit. So I am going to pass it back over to Bruce.
Thank you, Crystal. And thank you very much, Hakan, and for this wonderful and awesome presentations, sharing a lot of knowledge and information. So this concludes our presentations for today. So I just want to remind everyone, So we still have one more day with 3 sessions tomorrow. So we will start tomorrow at 11 a.m. Eastern Time. We're going to have a session on cyber warfare in the digital age. We will bring a couple of experts in this area, and that with David Katz, who is the Chief Information Security Officer at the Federal Reserve Bank of New York, and that we will have Daniel Guerrier, and he is a lawyer by profession, but is also Chief Information Security Officer and the founder of some cyber risk assessment group and so forth. And we also have in the afternoon at 1 p.m. Eastern Time, we will have Brian Sabriana, and that he is a MIT research scientist, and he is also the director for the IBM Research Lab, and that he's going to be talking to us the 4 stages design process for AI products with an emphasis on vulnerabilities. And so basically that is about AI in the context of security, and that he will basically touch on things like IoT and etc. Right, and then we will end our summit tomorrow at 3 p.m. We will have a networking session, and now that's the session that you want to attend to make sure that you get an opportunity to network with our speakers as well as others joining the session. We will have breakout rooms, but we will be making an official announcement of a brand new degree at 3 p.m. at the start of the networking session. So thank you very much, and thank you again, Hakan, for this wonderful presentation, and thanks everyone for participating. Have a good evening, and we will see you tomorrow.
Thank you.
Thank you very much.